Hello, welcome to my 5 experiments on Newton's 3 laws. Enjoy! Experiment 1 of Newton's first law is happening. Welcome to my first test of Newton's first law of motion. So here I have a Nerf gun and here I have a dinosaur. I will be throwing this one and shooting this one at this pail. We will see which one makes the pail move more. Nerf gun shot at pail. 3, 2, 1, boom. See, it didn't move very much. But let's try the dinosaur. 3, 2, 1. It moved a lot. That was my first test. Experiment 2 of Newton's first law is here. Hello, welcome to my second test of Newton's first law of motion. So in this part, I will be throwing this dinosaur at this shoe and this microwave oven transformer to see which one of these will move more. And this is very heavy. It's about 6.2 pounds. But this one is like less than a pound. But I can throw this pretty hard, so this will have enough force to move some things. But which one of these will it move? So we will throw them. So 3, 2, 1. And as you can see, it moved quite a bit. And when we throw it at the microwave oven transformer, we will see 3, 2, 1. No matter how hard I throw it, it just won't move. That was my second test. This is my only experiment of Newton's second law. Hello, welcome to my only test of Newton's second law of motion. In this test, I will be using these 12 magnetic tiles, this tissue box, and these 2 iPad second generations. The way I will do this is I will push these into this to see which direction this travels in. So I will do the test in 3, 2, and 1. And as you can see, the iPads push the tissue box in that direction. It's time for experiment 1 of Newton's third law. Hello! Welcome to my first example of Newton's third law of motion. In this example, I will be dropping this bouncy ball. Bouncy ball dropped. 3, 2, 1. As you can see, and as the name implies, the bouncy ball bounced. This is experiment 2 of Newton's third law. Hello, welcome to my second test of Newton's third law of motion. In this test, I will be trying to press my hand through the floor. 3, 2, 1. As you can see, I cannot press my hand through the floor. It's explanation time. Hello, I will explain to you all of my experiments that I've done. So first, we will start with Newton's first law of motion, which is that any object in motion will stay at motion, and any object at rest will stay at rest unless acted upon by an external force. So this Nerf dart has very little mass, very little inertia. And then this pail has friction and inertia, so it couldn't push it very much. But this dinosaur has a lot of mass, quite a bit of inertia compared to the pail, so it pushed against this pail's friction and inertia easily. Then, for example 2, this shoe has less than a pound of weight and not very much inertia. But this dinosaur throne has quite a bit of inertia, so it just pushed the shoe out of the way. But look at this microwave oven transformer. Isn't it evil? It has 6 pounds of weight, a lot of inertia. And this dinosaur is doesn't have very much inertia compared to the microwave oven transformer. As you can see, it's very evil. And the second law, which is that if there's 2 forces acting upon something, then the object will be pushed by the stronger force against the weaker force. So this is also known as net force, which is the net force will be in the direction, basically the one with a lot of force minus the one with some force. that's going in the opposite direction. This tissue box has minuscule inertia and not very little force. Force against the next force. This is a Kleenex. And these iPads have a lot of force, and these magnetic tiles have some force, so the iPads pushed it. Then for the third one, there's a bouncy ball. It touches the floor. It's the gravity and inertia together, along with the floor, which are equal and opposite forces, squeeze the ball, and the ball bounces back up due to its elasticity, which like causes the ball to decompress, and it pushes it back up. And then for my second example of Newton's third law, my hand pushing down, the floor pushes back with equal and opposite force. And as you know, Newton's third law is that for any force there's an equal and opposite force. By the end.